In this lesson, we're diving into the fascinating world of deep learning, a powerful subset of machine learning inspired by how the human brain works. At its core, deep learning emulates the way the brain learns by creating an artificial neural network. These networks simulate the electrochemical activity in biological neurons using mathematical functions. The term deep refers to the structure of the network itself, composed of multiple layers of neurons. These layers define deeply nested functions, resulting in models often called deep neural networks or DNNs. Deep learning isn't just about complexity, it's about versatility. It can be applied to a variety of problems, including regressions, like predicting continuous values, classifications, like categorizing data into classes, and then specialized in domains like natural language processing and computer vision. So, how does a deep neural network work? To understand deep learning better, let's look at an example classifying penguin species using neural network. Input features like X, this is the input data includes four measurement of a penguin: the length of the bill, depth of the bill, length of the flippers, and the weight. Predicted label or Y, this is the predicted of the species of the penguin. There are three possible classes: Adelaide, Gentoo, and Chinstrap. Here's how the deep neural network works step by step. First, the input layer. The input layer has one of the neurons for each feature. For example, if we use the vector 37.3, 16.8, 19.2, these values are fed into the input neurons. Then the hidden layer, each neurons in the hidden layer calculates the weighted sum and then output data. These sums are processed using activation functions to introduce non-linearity, allowing the network to model complex relationships. Neurons in one layer are fully connected to neurons in the next layer, enabling information to flow through the network. And then third, output layer. The output layer predicts the vector of probability of each class using functions like softmax. For example, the output vectors look like 0.2, zero point 0.7, zero point 0.1, representing the probability of Adelaide, Gentoo, or Chinstrap species respectively. And finally, prediction. The class with the highest probability is the predicted species. In this case, the network predicts Gentoo class A because zero point 0.7 is the highest probability. The true power of deep learning lies in how the model learns. It can learn by training. The model is trained by passing the training data through the network. Or for each input, the network predicts a probability such as zero point 0.2, zero point 0.7, zero point 0.1, and then error calculation, the difference between the predicted and actual values and the calculated as loss. And finally, the weight adjustment. The network adjusts its weight using algorithms like back propagation, a gradient, and descent to minimize the loss.